Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at biopotential electrodes. In the previous set of videos, we looked at polarizable and non-polarizable electrode and we gave some examples. What is an example of a nearly perfectly polarizable electrode? That is the platinum electrode, in which all the current or almost all the current is the capacitive or the displacement current. The other case is the case of a nearly perfectly non-polarizable electrode, which is the silver chloride electrode. In this case, the system almost acts like a short circuit, not exactly, because there is still some charge transfer resistance that is there. So, it is not R is equal to 0, it is not R equal to 0, but rather R is really small, the resistance is quite small, because there is still some resistance offered due to charge transfer. Also, as we will see during sintering, I will give some examples, the details of how the sintering process is done, where we particularly ensure that it is not a short circuit. There is a very good reason why, we will see that in this class. So, in this class we will look at the practical and most prevalent recording electrode, which is the silver chloride electrode. Remember that when it comes to stimulating electrodes, you prefer polarizable electrodes such as the platinum electrode. What are some examples of stimulating electrodes? Deep brain stimulation, pacemaker electrodes, defibrillators, etc. Right? What is an example? Platinum electrodes. When it comes to recording electrodes, we prefer non-polarizable electrodes. So, it is a function of what is the application. The most practical and successful electrode is the silver chloride electrode. Silver chloride electrode turns out is the gold standard for recording, or rather in this case the silver standard for biopotential recording. Silver chloride electrodes are practical stable electrodes, and it approximates, it is almost nearly a perfectly non-polarizable electrode, almost a non-polarizable electrode. The structure is, so you have a silver base on which silver chloride, a salt of silver, is coated with, and this is placed in the body in which the biological fluids have high concentrations of chloride ions. It is critical for this to work that we use this only in electrolytes that have a relatively large concentration of chloride ions. So, what are the ionic activity of the silver chloride electrode? First is silver oxidizes, that is silver becomes a silver cation and releases an electron. This is one. The other is this silver cation combines with the chloride anion found in the electrolyte, releasing the silver chloride precipitate. So, the function of this electrode is determined, or its effectiveness and efficiency of this electrode is determined by a product of activation level of silver, or activity level of silver and the activity level of chloride. The product of these two gives a constant called the solubility product Ks, which is essentially the product of the activity of the silver ions and the activity of the chloride ions. Note that this can vary depending on the concentration of silver and the concentration of chloride and the concentration of these in the electrolyte, concentration of chloride in the electrolyte, which is the body. So, and there are two definitive processes to fabricate or make silver silver chloride electrode. One is the process of electrolysis. In this process, typical electrolysis, electroplating, you have a silver cathode and you have an electrode on which you want to deposit silver chloride, which is this one, right. And then you have a current limiting resistor and a battery through which you send current. And you place this in a solution of sodium chloride or hydrochloric acid. When you do that, what happens? Electrolysis happens. This is essentially an electrochemical cell. In this case, silver is kept as the anode, and you watch for the drop in current through a multimeter, voltmeter current. In this case, you are monitoring the current, an ammeter or a milliammeter as the case may be. And then once the deposition is complete, you will see a sudden drop in the current, because silver is no longer conducting, because the deposition is of silver chloride, and you essentially stop this process. What are the advantages of this method? Well, the advantage is that the coating of silver chloride on the silver electrode is relatively uniform, as you would expect from the electrolysis process. The other process, the more practical electrode, more commonly used for long term recording, is the so called sintering process. In this process, what is done is silver powder and silver chloride powders are mixed. They are mixed well so as to ensure that there is uniform, relatively uniform mixing of silver powder, powdered silver, and salt, silver chloride salt. And you put this into molds and compress them very tightly with a press, very tightly with a lead included, and then you bake them, you bake this at 400 degrees Celsius. I might be wrong about the temperature, but do check. I think it's 400 degrees Celsius. Bake at 400 degrees Celsius. And after that, let it cool, then you have the sintered electrode. This is the other process. The fundamental difference between these two electrodes. The electrolytic silver chloride electrode is a little less rugged. It is possible during rugged use, some silver chloride coating may get scraped off from the electrode, essentially directly revealing the silver, in which case you are not going to get the ideal characteristic, because you are interested in having silver chloride on top of the silver electrode, because the electrolyte is a solution containing, which is the bodily fluids, which is a solution containing chloride ions. If silver chloride is getting scraped off, then you will not get the desired characteristics. This is, after repeated use, it is possible for silver chloride to be scraped off. The other possibility, that is one of the disadvantages of the electrolytically prepared fabricated silver chloride electrode. The sintered electrodes do not have this problem, but the sintered electrodes, the process is slightly longer and the process is slightly more complicated, is it not? Because I have to do many things. I have to get powdered silver and powdered silver chloride, and then use a press and mold and press at a very high pressure and make it into pellets, and then bake it and then make it with leads. That is the other process. Now, this scraping off of silver chloride from the electrode does not happen in the sintered electrodes, because these are relatively rugged electrodes that can be used repeated use. For example, these are the electrodes that are typically used in the hospital setting over a long period of time, repeated use, nothing will happen. What makes silver chloride electrode ideal recording electrodes? Because this reaction is reversible. This silver chloride precipitating is reversible once once the process is complete, you can again reuse it. So, making it an ideal electrode with no change or minimal change in characteristics. So, fundamental advantage of using these as the recording electrodes. But in the case of silver chloride electrodes, especially the sintered ones, if you have the mix of silver chloride, the proportion of the silver and the silver chloride, these powders, when you mix them, if there is too much silver, then it is possible for silver metal to form direct contact with the body from the lead to the bodily solutions, thus essentially providing a short circuit, which is not a desirable solution, which is not a desirable situation, because you are interested in having chloride ions. So, there should be just enough chloride ions that the impedance is not very high, but not too much chloride ions that the impedance is high. That is, if you have too much silver chloride, impedance becomes very high. If you have too much silver, then there is short circuit. So, there is such a thing called as an optimal silver and silver chloride mix that you can then use in the electrolysis process. That you can then use in the sintering process. So, if you mix silver chloride salt, if there is too much silver, then there might be short circuiting. If there is too much silver chloride, then there might be a high impedance that might be there. So, you essentially prefer having a relatively low impedance, but not direct short circuit. This is the desirable feature of the silver chloride electrode, and you need to optimize for this proportion of silver and silver chloride salt in the silver chloride sintered electrodes. So, something to keep in mind. This is the point that I was saying previously, that it is not essentially a full short circuit. In fact, the full short circuit is not a desirable situation. There should always be some resistance, and I mentioned why there is this, because of charge transfer in the previous set of videos. Note that silver chloride is sparingly soluble in water or other fluids. So, that reaction that is that silver chloride makes with other chemicals is minimal, which is why it's a great option for recording. And chloride concentration being relatively constant in the biological fluid, it provides a stable recording solution. Silver chloride electrode is a relatively stable electrode. What is the half cell potential of this? I can measure this, that is essentially the E naught plus RT by NF, which is a modification of the Nernst equation, RT by NF times ln of activity of AC. This is the half cell potential, and so for the silver chloride electrode, this is essentially E naught of silver and the activity of the silver ion, and I substitute this in the previous equation, where the activity of silver and the silver chloride, essentially the product of these two provides the solubility product Ks. I use this to, in this I essentially substitute for Ag plus as a function of Ks divided by ACl. So, essentially this solubility product is a limiting factor in my design. So, then I will end up with E naught Ag plus RT by Nf times ln Ks by RT by Nf times ln of the activity level of the chloride ions. So, I could, so this is the silver chloride electrode. So, there is a silver metal on which there is a silver chloride surface or coating, and this is dipped in an electrolyte that is containing chloride ions, a large amount of chloride ions, and these are the reactions. Silver essentially gives, we already saw this, silver essentially gives silver cation and electron, and silver cation and chloride essentially gives silver chloride precipitate, which is a reduction. So, silver, I can compare another comparable electrode, nearly perfectly non-polarizable electrode, is the Calomel electrode, which is quite frequently used as a pH electrode. Calomel is essentially mercurous chloride, and so this is the composition of the Calomel electrode, whereas silver chloride or silver chloride electrode is frequently used for biomedical recording applications. The noise characteristics of the silver chloride electrode is very low, whereas in the case of the Calomel electrode it is relatively moderate. The drift that you see with the silver chloride electrode is actually quite low, on the order of 1 microvolt per hour, which is quite low, which is why it is a very stable electrode, and I can reuse this for many cycles without damaging, especially the sintered electrodes. But in rough use, electrolytic silver chloride electrode may not be the perfect solution, because silver chloride coating may get scraped off. I already mentioned this. Why is this the ideal biological recording application solution for biological recording? Because there is stable chloride concentration. Because of that, there is a stable potential that is there because of the dependency on chloride concentration, because chloride concentration is usually stable in the biological system, and the drift is relatively low, minimal drift. I already mentioned this is about 1 microvolts per hour. So, it is very reliable for long term measurements without changing significant potential variations. So, variations will not change, potential will not change by a lot. Then biological compatibility, it matches very well with biological fluids. So, the chloride rich environment of the biological system, such as plasma and extracellular fluid, is extremely well compatible with the silver chloride electrodes, and the noise level is very low. So, and there is quite a limited amount of interference from other ions. Here is a comparison between the Calomel electrode and the silver chloride electrode, and so you have the mercurous chloride and KCl paste, and in which you have the saturated potassium chloride solution, and then you make the measurement of pH using this electrode. pH is used for pH measurement. This is used for biopotential recordings. So, these are the advantages of the silver chloride electrodes. So, there is a typical half cell potential of about 200 millivolts. typical half cell potential, which is quite reasonable for biological biopotential recording applications, right. And it is not toxic. Silver being a noble metal is not toxic and highly biocompatible. And if sintered electrodes can be reused, well maintained sintered electrodes can be reused for thousands of applications, thousands of cycles without getting damaged. So, essentially provides a stable, reliable, low noise, highly biocompatible, minimal drift solution, which is the silver chloride electrode. So, with this we come to the end of this video. In this video, we looked at silver chloride electrodes in good detail. With this, we end this video. Thank you very much for your attention.